Hello students, in this video we are going to understand the concept and also solving the pentagonal prism with just one face added to a square prism which we have solved in the previous problem. So here it is a pentagonal prism of base side 25 mm, height is 50 mm, resting it on HP on one of its base corners such that one of the top edges is at a distance 60 mm above HP, that is nothing but the surface inclination. Draw its projections when its top view of the axis is inclined 45 degrees to VP. That means what they have given is the apparent inclinations. So initially, so I have just represented the pentagonal prism. This is A, B, C, D, E. So in top face we will be able to see A, B, C, D. In the bottom face A1, B1, C1, D1 is not seen. This is the front view. The visible faces are going to be thick lines, invisible is going to be thin lines. Line joining E1 is going to be hidden, so it is going to be inside the bracket. If we are going to be solving the problems, the first step is projection of whether we are going to solve prism or pyramid. So in this case we are going to solving about the projection of prism, that is nothing but the pentagonal prism. So it should be resting it on HP as per syllabus. So we are going to be resting it on corner, which is nothing but SP2, and the corner should be on the right side. This is very important when we go to solids because we are going to tilt towards the right. That is the reason why we are going to keep the corner on the right side. If you are going to keep it in the left side, you are going to tilt towards the left side. Let's understand how you are going to be drawing it manually. Initially I am going to draw a side length which is equals to 25, and from here I am going to draw a line, side length 25, and it is being inclined to 72 degrees. So this should be 72 degrees. Similarly, I am going to draw a line from here. When you are going to draw it, you are going to draw it symmetrically. Even from here, it should be 72 degrees. Again, from here, this length should be 25 and this should be equal to 72 degrees. From here this is going to be 25. When I'm going to check this, it is also going to be 72 degrees. I'm going to draw the perpendicular bisector. This point should be exactly at the center. So this length is 25. From here to here, this should be exactly half of it, which is 12.5. Then whatever the pentagon you have drawn is going to be regular pentagon. If you need to verify the pentagon is regular or not, sometimes you may take it as 68 degrees instead of 72 degrees. So I am going to draw this line. These are nothing but the perpendicular bisectors. Then draw a circle. This is just to verify whether you have drawn regular pentagon or not. Then it should touch all the corners of the pentagon. When you need to draw this perpendicular bisector, you can just go for an arc of any radius and you can draw it. If it is touches all these corners, then the pentagon what you have drawn is a regular pentagon. After this, you can just delete all the construction lines. This is just for your reference. If you're going to draw irregular pentagon, then the entire problem will be goes wrong. So you need to pay more attention for drawing this pentagon. Now here what we are drawing is nothing but the prism. We need to rest it on corner. So corner should be on the right side. Then we need to write its annotations. So here this is the pentagonal prism. So in top view I'll be able to see A, B, C, D, E. Corresponding ends A1 is not seen, B1 is not seen, C1 is not seen, D1 is not seen, E1 is not seen in top view. So here I'll be representing its annotations. So this point A is seen, but A1 is not seen. B is seen, but B1 is not seen. C is seen, C1 is not seen. D is seen, D1 is not seen. E is seen, E1 is not seen. Now in the same way, axis point O point is seen, that is top face is visible, bottom face is not visible. That's why we are going to mention O is seen but O1 is not seen. We are going to be drawing its projections. From here it should be thin lines. We need to even project this line. This is the axis line projection, not the axis line. The height of the prism is 50. So I am going to draw a line. From here this measurement is 50. I am going to draw a line till this point. Then I am going to be drawing it. So this is what we are going to see in it. So this is the front view. We have got the same view here. So first thing is, as soon as you make it, make sure you're going to give the dimensions. Now here in the front view, this is A, this is A1 is seen, B1 is seen, C1 is seen, but D1 is not seen, E1 is not seen. So here I'm going to see it from here. So this is the perpendicular bisector. The first nearest point is BB1. So this is the first nearest point. Second nearest point is AA1, then CC1. So beyond this half of the solid you're going to be able to see it. Beyond this half you're not able to see it. The first nearest point is BB1, second is AA1, then CC1. That is going to be visible. So here A dash is seen, but E dash is not seen. Here B is seen, but D dash is not seen. Here C dash is seen. Similarly, here corresponding points are A1 dash, E1 dash is not seen. Here B1 dash is seen, but D1 dash is not seen. Here C1 dash. Next thing is I need to draw its axis line from here till here. Axis line should be axis, we are going to draw it, which is O dash, which is not seen. O1 dash is also not seen in the front view. In second step, we need to see the inclination with respect to HP. So here it need to be resting it on corner, which is nothing but the base corners, and instead of giving the inclinations he has given the height. So here we are going to tilt it, the pentagonal prism, till the opposite end, that is nothing but opposite is nothing but this edge, top edge, which should be a height of 60 mm. So we are going to create a plane where from the base to this plane height is 60 mm. So here I'll be drawing the line, height is 60, here I have just created a locus line where the height is 60 mm above HP. So here what it says, it is resting it on corner and the topmost edge, so that is nothing but the topmost edge is nothing but this edge, which is going to be at a height of 60 mm from its base. So it is not mandatory that we need to keep the corner on the right side. We can even keep it in the left side also, but you need to tilt the other way. So suppose if I'm going to keep corner in the left side here, I can tilt towards the left, but finally what I need is it should be resting it on corner. The reason why I keep it on the right side is because most of the books is going to be tilting towards the right. To avoid the confusion when you're going to refer with my video, I'm just going to keep it all right on the right side. So what I need to do is I need to draw this pentagon till in such a way that the corner C1 should be on the XY line, AE should be at this height, which is something about 60 mm. So I'm going to draw a construction. It's just a reference. That means construction lines we are going to draw it in thin lines. Later if you want you can draw it. So I'll just find this length, what this height is, 63.09. So now I'm going to create an arc on this 63.09 and I'll cut an arc. So here I can cut this at 2 points. Even you can keep it here or else you can keep it here. Both are correct. So if you just refer any books with respect to this, they have kept it here. It is not wrong if you're going to keep it here. Finally we need to keep it this edge which is at the height of 60 mm. Now I got this point. I am going to find this distance from here to here, which is at the distance of 38.47. I'll cut an arc from here. I'll cut a 38.47. I've taken it from here to here. Already I know this point, which is nothing but, so this point is nothing but here. The point which I have cut it here is this one. This is nothing but A dash. I'm just preferring to keep this one in the second point. So I'm going to take the distance from A dash to A1 dash, which is equals to 60. I'll go for arc by point. From here cut a radius of 60. Now I'm going to draw a line . Till this point, and from this end I'll be joining it. So I'll cut an arc which is the radius is nothing but 38.47 from A dash to A1 dash, which is equals to 50. So I'll go for arc by center point, move to this point, and from here with the compass you're going to draw a radius equals to 50. After cutting an arc, I'm going to join it from this point to this point and this point to this point. When you're going to drawing it, make sure that this is equals to 90 degrees, because lateral edge with respect to base is exactly perpendicular, so it should be equals to 90 degrees. Now from here to here again I'll just go for arc by center point, or else you can use a roller scale and draw lines parallel to the base and the lateral edges, or else you can just draw an arc which is of the radius is 50, and from this point which is equals to 38.47. Then just rub this. Don't retain any construction lines. So this is how you're going to be constructing it when you're going to do it manual sketching. So I'm going to rub all these construction lines. Now do not keep the annotations below the XY line. This annotations belongs to VP. Keep this here. Now I'm going to be concerned about the second step, which is C dash to D1 dash, and this also is going to be equal to 50 and it is going to be parallel to that. So I need to find its distance. This distance is 14.69. I'll cut a radius with the compass here, 14.69. Don't cut it from here. We have taken distance from C dash, so you're going to cut it from C dash itself. Now you can make use of roller scale and draw parallel lines, or else with the same way you can cut it arc at the bottom and draw the line. Now I need to find the axis distance. So from here, what is the distance from this point to this point, which is equals to 21.27. so again I'll cut an arc. So from here 21.27, I'll cut an arc. Then select this. You can just draw parallel lines. When you're going to draw a line, this is the line. What you're drawing is the axis line. Do not get confused with the edge and the axis line. This should be in axis line 0.13. Do not retain any construction lines. Delete it. Now the same annotations we are going to keep it. So this is just for your reference. I'm not going to retain any of these dimensions, neither this diagonal. This is just for the reference. Now I'm going to take the annotations. So annotations remains the same. So now I just placed all the annotations which belongs to the first step. So second step is going to be you need to find the inclination with respect to HP. In this case, instead of giving the inclinations with respect to HP, he has given the height. That means we need to find the true inclination with respect to HP, that is nothing but theta. So here theta is equals to 34 degrees. Now let's project its top view. So the top view, this is just a reference plane, so I'm going to remove it. Now in top view we are going to be able to see three faces. In first step we were able to see just the pentagon. In the second step you are going to be able to see three lateral faces and one top face, and outer boundary you can see all those edges are going to be visible. So that is what first we are going to do it. So first thing what you need to do is you're going to do projections. Start with the letter A. I'm going to draw this A. Again from B I'm going to draw it. Again from C I'll be drawing it. Again going with the D point, I'm going to draw it. I'm going to draw it with E also. So we are going to do the projections from its top view. So I'll go for the line, this is A dash. I'm going to project this line till the point where A is. This is the A dash. Then going for the point B dash. B is till this point. Then C dash till this point. Similarly, I'll go with A1 dash is still here. Then B1 dash is still here. Then C dash is still here. I'll write the annotations. So this point is A, this is B, this point is C, and this point is D, and this point is E. Similarly, this one is A1, this one is B1, this is C1, this is D1, this one is E1. Here outer boundary is visible, so we are going to join the outer boundary of the pentagonal prism. So I'm going to join the outer boundary. I'm going to remove all this projection lines. Next thing is we need to see the nearest point for an observer. So nearest point for an observer is A dash E dash is the nearest point for an observer. Here in the top you can see this is nothing but A dash, this is E dash. So line joining A dash is nothing but it is joining to B, A to B, A to A1. This one is joining A to E. This one is E to D, E to E1. Here I'm going to join this in thick lines. So this one is A to B is seen, A to E and to D, then A to A1, then this point is till this point. So which is the farthest point? The farthest point is C dash. So that means which is nothing but the base corner here. So in top view we are not able to see that. So line joining the base points, this edge, this is nothing but the C, this is nothing but C1, this one is are the edges which is not going to be seen in the top view. So here the farthest point is C1 dash. So from C1 to B1 is dotted line, dotted line. So this one is dotted line. Line joining C1 is everything is dotted. So I'm going to keep this inside the bracket. After projecting all this, we are going to project the axis line. I'm going to project this O dash till this point and from here till this point. So now this point is nothing but the top face. This is nothing but the top face. Here O point is seen, but O1 at the base is not seen. So if one face is visible, that means all those things related to that is going to be seen. So this one is O, O1 is not seen inside the bracket. So we found the theta value. In the second step we understood how to draw its top view. The next step is draw its projections when the top view of the axis is inclined to at 45 degrees to VP, which is similar to the next step is to see the inclination with respect to VP. Here inclination with respect to VP is when the top view of the axis is inclined 45 degrees to VP. This is nothing but the top view. Second step is going to be inclined 45 degrees to VP. So that means we are going to take this prism and incline the axis 45 degrees to VP. This top view has been inclined, which is almost like in most of the problems where the axis appears to be inclined. So I will take this, I'm going to draw 45 degrees line. So as soon as you get it, you are going to be drawing the angle which is going to be 45 degrees. Now I'm going to draw only the top face. I'm going to take this distance from C to D and C to B. So what is that distance is, which is equals to 21.86. so I'll go here, arc by, I'll take some point, make sure that the top view will not cross over the XY line. From here 21.86. Similarly from here I'll measure the compass, this distance, and cut an arc. Next is I'm going to take the distance from C to C1 distance. If C to C1 is 41.45, then all these edges will be equal to 41.45. This is also 41. This is also 41.25. This one is also 41.25. So now I'll go for drawing. Move to this point. From here I'll cut a point 41.25. This one is nothing but C1. Now I'll take the distance from C1. After cutting an arc, I'm going to take the distance from C to this point, which is nothing but 21.74. I'll cut an arc. So move to this point with the same point, nothing but C point. I'll cut a distance of 21.47. Now this AE line is exactly perpendicular to the axis line. So I'm going to draw a line perpendicular to this line. Now I'm going to take the distance from this point to E, this point A, which is exactly 12.5. Go for from this point. I'll cut an arc. This point is nothing but A point. This is E point. Now I need to find the point D. C point was the first point. Now I'll take the distance from E to D, which is 15.5. From the same point From A point I'll be cutting it, which is 15.5. Now I'm going to join the pentagon. Once this is drawn, you can just delete it. So make sure this is going to be exactly perpendicular. After drawing this, I know this all these edges is going to measure 41.25. So even if you're going to select it 41.25, 41.25, 41.25, even distance from O to O1 will also be 41.25, A to A1 will also be 41.25. So now I'm going to draw a line from this. Take the roller scale, draw the line parallel to that, which is equals to 45 degrees. I'm going to draw a line. I'll take an arc by center point. From this point I'll cut 41.25, drawing an arc. Then I'm going to then draw parallel lines from each of these points. It can be any length. Draw parallel lines which is going to be equal to 45 degrees. Even cut the point here also. Next thing is I'm going to take the distance, and from any lateral edge length is 41.25, which is nothing but an apparent length. With 41.25, take the radius. I will cut an I'll cut a radius of 41.25 radius. I'll just cut an arc. After drawing this, the same way you are going to cut an arc at all the points. Take the same distance. Then from here also I'll cut an arc with the same radius. Then from here also I'll cut the same radius. Here also I'll cut the same radius. After cutting radius at these points, now I am going to be joining this. Now when you are going to take this length and this length is equal and parallel. All these lengths will be equal because we are going to take the same radius, and this face what you're going to say and this face will be similar. Rub all the construction lines. When you're going to do the same thing with the Solid Edge software, directly copy paste. It's just a one step. But when you're going to do it manually, you need to be cutting so many arcs. I'm going to write the same annotations, and this is going to be hidden lines. I'm going to write the same annotations. E1, next thing is this line. I need to find the axis point. So now I'll take the distance from this point to this point, which is 12.02. So I'll cut a radius. Next, from this point, which is equals to 41.25, all the lateral edges and axis is going to be the same line. So I'm going to represent the axis line only from this point to this point. This should be in thin lines. So axis line will be dominated by hidden edges. Hidden edges will be dominated by visible edges. So this one is O1. Even here, even in the second step, I need to be representing the axis line. So we found the inclination with respect to VP. How it is seen in the top view is this is what we are going to see it. We are going to be able to see three lateral faces, one top face. So 1, 2, 3 lateral face, one top face. Now we are going to see the projections in front view. So in front view, we're going to be able to see it like this. That means base is seen, 3 lateral faces is also visible. So we are going to be drawing the projections. The third step is we need to get the front view. First we are going to project it from A dash, then go for draw these lines, then C. Project this A till where A is, then go to this B point. B point is B dash is here, then go to C. C is still here, D is still this point, E point is here. So I'm going to rub all these excess lines, retain only whatever it is to be kept. So now give the annotations. So this point is A dash, this is B dash, this point is C dash, this is D dash, this is E dash. Same way, now we are going to go for projecting the bottom face. So this one is A1 dash, E1 dash, then B1 dash. Go for A1 where it is, A1 till where A1 is, B1 is to this point, again going for C. C point is at the XY line, D1 is still here, E1 is still this point. Now I'll give the annotations. Start with the letter. This point is A1 dash, this point is B1 dash, this point is C1 dash, this one is D1 dash, this one is E1 dash. Now Now we need to join the outer boundary of the solid. Now you can see it here. Outer boundary of the solid is this is what it is, resting it on corner on HP. Opposite edges which is 60 mm above HP. Same way here, outer boundary need to be drawn in thick lines. B, move to the point C because you cannot join C to B to C1 dash. You need to go to the C dash. C1 is the edge which can join C1. There is no edge from C1 to B like here. Then from D1, then here. Outer boundary is done. Then same way we need to see the nearest point for an observer. Same way I'll be just drawing an imaginary line. The first nearest point for an observer is A1. So line joining A1 must be in thick lines. So go for lines. A1 is joining to A dash. A1 is joining to E1. Then A1 is joining to B1. Then the second nearest point for an observer is below the axis point. So this is an axis point. We just consider the face. This is an axis point. A1 is the first nearest point, B1 is the first nearest point. Farthest point for a base is D1. Second farthest is C1, then E1. Even the same thing, it is going to be correspond with respect to the solid. This is the axis point. So first farthest point is the D point, second farthest C, third farthest is E. So you are going to consider it the axis point, imaginary horizontal line here. First nearest point is A1, B1 is the second nearest point. Similarly, B1 should be drawn in thick. Nearest point is B1. So B1 is joining to C1, B1 to A1 is already drawn, then remaining is B1 to B. Now you need to see the farthest point. So farthest point is D point. So it's an imaginary line. First farthest point is D, second farthest point is C, third farthest point is E. So I need to go for the first farthest point, which is nothing but D. Hidden lines from D point, it is moving to E point. D point, D1, D to C. Now the second farthest point is first farthest, second farthest C. Above this axis point O. So from C point it should be hidden. C is joining to B, which comes under the outer boundary, no changing. C to C1 is again the outer boundary, I am not going to change. C to D is already made the hidden lines. So there is nothing left with the C. Then let's move to the third farthest, which is E. So E to E1 comes outer boundary, so it is going to be thick line. E to A is outer boundary, thick line. Remaining is E to D, which is going to be done, which is already been done. So line joining D is all hidden, so we need to keep this one inside the bracket. So this is the same way I'll be able to see one face E1 A1 A1 B1 B is what you're going to see. This is the first face, second face, third face, and one bottom face is seen. Top face is not seen here in the front view. Now we are going to project the axis line. Axis line should be drawn. This is the point O. Project till here. First thing is I'm going to project the horizontal line. This is O. I'm going to project this one till here. This point is projecting till this point. Similarly, I'm going to project it till here. So this is going to be a line, should be thin lines, should be axis line, thin line. All this line is also going to be equal to the same line. It is going to be parallel. Now here you can see A1, B1, C1, D1, E1 is the face is seen. So that means here O1 is visible. Here A, B, C, D, A dash, B dash, C dash, D dash, E dash base is not visible. So we're going to keep it inside the bracket. So which is similar to the problem which is going to be like this. This is the front view. Same thing what we get. Hope you understood. Have a good day.